Hey, hello, and welcome to the show. It's me, John Park, and it's time for John Park's workshop on this Halloween edition. So thanks, everyone, for stopping by. I know everyone's got a lot of Halloween plans and things to set up and prep, especially if you're a few time zones ahead. You're probably already thinking about getting trick-or-treaters or going out and treating yourselves. So thanks. I appreciate you joining me here. So what have we got going on here today? I have a coupon code for you so that you can save a little bit of money over there on the Adafruit shop if you're interested in getting some stuff today. I've got a recap of my show from Tuesday, the Product Pick of the Week show, which they were not able to do an Ask an Engineer last night, so there was not a recap yet of that. So hopefully that'll be the chance for you to see it if you haven't seen the show. I actually, due to Halloween things, don't have as much time as usual, so I was not able to put together a CircuitPython parsec for this week, but I will be back with that segment next week. I do, however, have a couple of new neat things that we'll be doing. I'm going to do a bit of a gear report type of thing on a Game Boy cart flasher and ROM dumper, so we'll start looking at the hardware side of things on homebrew Game Boy game creation, and hopefully I'll be able to do a live demo of that. I just had the software I've been using elsewhere, but I just set up the flashing software here earlier today, so hopefully we'll be able to do a live demo so you can see what that's all about. And then we'll be diving into a little bit of DMX512 lighting and fixture control kind of stuff, both sort of a general intro explainer as well as starting to look at some microcontroller based solutions for dealing with stage lighting, theater lighting, club lighting, architectural lighting, a lot of different lighting, as well as other things, fog machines, motors, etc. use DMX as a way of sending messages around, so we'll look at a bit of that. And that should do it. That'll be the show. So first of all, I want to say thanks to people for stopping by. Hello, Andrew Farnsworth over in our YouTube chat. If you're watching on YouTube, you can always join the chat over there if you are there or elsewhere that doesn't seem to have a live chat going on. You can head on over to our Discord, which is this right here. It's adafru.it/Discord. That'll get you right over there into the Discord channel. Sorry, I'm just gonna change a setting here on that. There we go. On my air, just so we have a little air blowing into the shop. You can see I'm optimistic that it's fall-like with my flannel here today, but it's actually not that cool here in Southern California. There we go. Watch that wire. chat at Adafruit Discord. You can head over there and then look for the live broadcast chat channel. So hello, and thanks to people for stopping by. Thin Man, C. Grover, Paul Cutler, hello, Toddbot, Mark Z, thank you. Hey, Snaky Maker Cat, with your, oh my goodness, Cyclops GIF there. Sorry for the low-ish effort costume here. I didn't have. Lars got dressed up. He borrowed another mask there. I've got some of my old masks from previous Adabox, actually. Adabox a couple ago, I did some Twilight Zone stuff, so I have some of these different things. So let's start off with a coupon code. So if you head over to Adafruit, you can just go to adafruit.com, and you will see a bunch of banners and things, enticements to get some cool stuff, some products that we've got, new stuff over here in this new products section. We've got a bunch of product categories, and if you find some stuff you want and you'd like to get yourself a discount on them, then use that coupon code today. It's All Hallows Eve, because it's All Hallows Eve. This is Halloween, so type that in, ALL-Hallows-Eve, and that will get you 10% off in the store today until about midnight tonight. Then it'll go away. And that is good on any of the physical stuff you can buy, new stuff, old stuff, as long as it's in stock stuff. We don't do back orders. But you can get stuff. You can't get gift certificates, subscriptions, or software with the discount, but pretty much all of the physical stuff you can. And I'll mention, if you are interested in spending a bunch and getting some neat free stuff, you can find out all about that right here at adafruit.com/free. If you spend $99 or more, you will get your stuff and this coaster right here, this free PCB coaster with the Adafruit logo on top. If you spend $149 or more, you'll get the coaster as well as a KB2040 microcontroller for free. If you spend $199 or more, you'll get both of those as well as free UPS ground shipping. And if you spend $299 or more, you will get a Circuit Playground Express microcontroller, easier for me to think than say, as well as the UPS ground shipping in the continental US, and the KB2040 and the coaster. So those are all some things that you can get for free if you spend a bunch, and we appreciate that, because that's how we run the whole operation here at Adafruit, is by selling stuff to you. And this, I moved the wrong thing. This coupon code right here, that's your key. That's the secret to getting 10% off today on Halloween. So you can use that till midnight tonight, East Coast time in the US, and save a little bit of money. Andrew Farnsworth says Doom has some of the best audio sounds for Halloween. Oh yeah, I should get a soundboard thing set up, shouldn't I? Play some creepy Doom stuff. Good point. What is going on over here? There's another confusing GIF in the chat. Who's this cow? What's this cow all about? I don't know. I don't understand. So, what else? Let's, like I said, I don't have a CircuitPython parsec. Oh, but I do have my recap from the Product Pick of the Week show. So on Tuesdays, I do the Product Pick of the Week show, and I usually give you a big discount. We do, not just me, we. Special thanks to the product team at Adafruit, new products. And so we pick a thing, and this is one that I like. I've used it a lot in various projects, including the Air Blaster this year. And on the show, I do a little bit of a recap, or rather, I do a little bit of a demo, give you the specs of it, give you the big discount. But what I like to do is then excise a little 1-minute section so that you can see that later. Here is the recap from this week. It is the Power Relay Featherwing. It is terrific for switching high power stuff. I have this jumper closed. That one corresponds to pin 10. And whenever you set that pin to high, in this case pin 10, it will close the relay and then allow that larger current to flow through there. I have a little button here, a little switch. When I press it, it will start opening and closing that relay, which in turn opens and closes my solenoid because it's sending the full 12 volts through there. And I can turn that back off. Use it for just 0.025 seconds and then dwell in a pause mode for just 0.07 seconds, so it'll be pretty fast. And there we go. Tick, 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 tick. I love this thing. It is fantastic. It is the answer. I don't know what your question is, but it's probably the answer. It is the Power Relay Featherwing. Yes, indeed it is. So, sorry, I was riding the faders a little there. That seemed a little low. Hopefully I'm not peeking out the mic here. I just want to try to get the audio level good. All right, so what else is going on here? Like I mentioned, sorry, I don't have a CircuitPython parsec for you today, but we actually will be dealing with a little bit of Arduino stuff a little later as we get into some of our DMX things. I mentioned we'll be doing some DMX stuff. We'll be doing some Game Boy flashcard stuff. I'm also going to do a continuation of parametric modeling and CAD 3D using Rhino today, starting to look at dimensioning a enclosure for a PCB, that kind of thing. So that's another little bit that we'll be doing a little later in the show. But right now, let's take a look at some of this Game Boy stuff. So let me go to, how about this view of the world there, and let me I can actually share, if it'll let me. I'm going to share Flash GBX software. I might have to scale it up. So give me 1 second to convince this to show that. Let me hide that away. Yeah, let's do a screen capture of this. Maybe I'll do a monitor section. All right, hold on 1 second. Sure, that should do it. Right there. Oh yeah, that's nice and big. Okay, I can scale that down a little. So what we're going to show here, so we've been taking a look over the last couple weeks at creating homebrew Game Boy Color games from scratch using GB Studio. I demonstrated taking an exported file in Pocket format, putting that on an analog Pocket, which is a modern FPGA-based handheld. But what I wanted to do was show how do you actually get your game as a ROM onto a real cartridge so you can play it on original hardware, unmodified hardware. There's, you know, approximately 70 billion of these things floating around our planet. So there's a lot of Game Boys out there. This is a little Game Boy Color. These are kind of neat. I've got an original Game Boy here that I put a backlit screen on, which actually, as it turns out, is much easier to see. It's also much harder to video. So this one looks terrible on screen, I was noticing. So I think this Game Boy Color will be a better way to demo it. And the key to this is that there are cartridges, and you can see, not that one, right? That's an original Tetris game cartridge. But there are things like this, made by Ferrante Crafts. This is a flash memory. I think this one does 512K sized games, and then it has some logic chips to act as a memory bank controller because the Game Boy doesn't know how to deal with more than 32K at a time. And then there are these clone games. So this is one that I got for $4 on AliExpress and $4.29, something like that. And it is a reflashable cartridge that contains a game on it, but you can reflash that with whatever game you want. So I'll leave that one out, and we'll try it on both. And then the key is having a gizmo that can, let me go to the full down cam view here for a second, a gizmo that can flash a cartridge. So this is the one I've been using, and I really like it. It's called GBX RW. And I can't remember if this is an open source project or not. I think it is. I'll show you some links in a minute. But what this does is allows you to plug into your computer over USB-C and then plug a cartridge into it and both read the cartridge, we'll do that first, and write a game out. So I'm going to switch over to this view right here. I'm running some software over on the side here. This is called Flash GBX. And, oh, Squid.jpg said they have this one too. It's a really neat cart flasher. So what I've done, I've plugged in a Tetris, original, real, genuine Tetris game here into the GBX cart flasher, GBX cart RW flasher. And then in this Flash GBX software, I can connect or disconnect to the board. So I'm going to reconnect to the board. I'm not going to update the firmware right now. It'll ask me that. And then I'm going to pick a mode, either Game Boy, which will handle Game Boy and Game Boy Color, or Game Boy Advance. So this is a Game Boy game. I'll click this first link, and you can see here it has read the header on the ROM on this cartridge, and it says, okay, the game name is Tetris, ROM title Tetris, code DMG, that's the Dot Matrix Gamer, the original Game Boy, DMG TRA-1. A lot of this stuff just comes from a database, so there's a little bit of info and then a big text file is being read right now. Lets you know if it has a real-time clock. Some games do, this one does not. Lets you know if it has a boot logo. So when you start up a device without a cartridge in it, you'll usually get a little block there instead of the word Nintendo. That's because that Nintendo logo actually is on the cart itself. You can see on this one the word Game Boy is on the device, but with no cart in here it doesn't display that. So this is a genuine game. It's going to definitely have that boot logo of Nintendo. Normally you can't change that so easily, but now with different capabilities on flash ROMs you can. So you'll see some of these will actually also have the Nintendo logo, even they're not genuine. So it probably used to be a form of piracy protection, but it's not as valid anymore. And it's telling me some key info. ROM size, 32K. So this is a single memory chip on the board here. That's it. It's dead simple. It's just mapped out to the edge connector that goes into the cartridge slot, but it does not have more memory than the Game Boy itself can read. Bigger games got around this, most games after the first batch got around this by using a bigger ROM size and a memory bank controller that could go and grab from separate little 32K slots and put those into memory as needed. Save type, this is telling me this one does not have a save capability, so there are FRAM chips and save chips and batteries on some cartridges. This one doesn't. When you may have forgotten this, but back in the old days when we played something like Tetris and you got a high score and you put your name in, that all got erased the moment you turned off the game and took out the cart. So this one does not have a mapper because it's only using 32K. And it just shows up as a genuine, a rather generic ROM cartridge. You can see this has a little database of some of the different common reflashable cartridge types. So this one can't be reflashed. What we can do, though, we can get deeper analysis on it, analyze the flash cart, which won't reveal much about this one because it's not a remappable one. Gives us some of the same info we just saw. And then we can do a ROM backup. That's kind of all we can do with this one. On games that have a save, you can also do a backup save, which is great because if you're particularly with games that are long RPGs or games that have collectibles in them like Pokemon, if that save data gets corrupt on your cartridge, you've lost all of your hours and hours of gameplay. So you can back up your save data off of games that have that, which is pretty cool. And you can also just back up the ROM. So if you've ever had an emulator and found a ROM somehow in a dark corner of the internet, wonder where that came from, it's this process. You put a cartridge into a reader, we click backup ROM, and I'll put this in view here. I'll just put this on my desktop, say. I make that sound easy. Where'd my desktop go? I lost the quick link to it. Let's go here. Desktop. And Tetris World Rev 1 GB. Game Boy. All right, I'll hit save. That's it. It was very quick. It took less than 1 second. We can generate a dump report. It gives us things like ROM checksums. We can then go and open that game and play it with an emulator or write it out to a rewritable flash card. So I'll do that, in fact. That'll be kind of interesting. So what I can do now, I like to disconnect from here, and then I can unplug my cart flasher, unplug my cart. If I now grab a rewritable cart like this Ferrante Crafts one, I can plug this in. Actually, let me show you first what this has on it. This will have my homebrew game, I think was the last thing I put on there. So I'll turn on game there. You can see, so it's got Lars Co games. So this is my little homebrew game I've been working on, Dorky Demustard. So what I'll do is turn that off. Let me switch the camera back. I will take that cartridge out, put it into the ROM flasher here, reconnect, tell it that I'm dealing with the Game Boy side of the world. So you can see this is showing up as, yeah, it's got Dorky, that's the ROM title I gave it, Dorky Demastered. It happens to be, it's saying a 128K ROM size, which is cool. I thought GB Studio could only write 512 as its small size, but maybe they've made some fixes because my game is pretty small, so it actually fits on 128K. Has a save type. There's SRAM there that can save. And here it's listing out the mapper type. It's a MBC3 mapper. And the profile. So what I can do is actually write a ROM to this. Oops. Let's pick write ROM. Here it actually does some better. I think there's a bug or something. This is actually correct info. This is saying that it is a cart type, not generic ROM, but DIY cart with a SST39F040 and audio. I can get some more details from that there. Compatible cartridge types, these just must be things that are in the database of Flash GBX. Even though it showed up as DIY cart with blah, 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 this one is specifically a Ferrante Crafts cart 512. So what I can do now is it's asking me to pick a ROM, so I can go to my desktop where I put that Tetris World Rev 1 GB. Open that. It's writing it 3 seconds. It says it's verified it. Okay. And now you can see it's showing up as Tetris, kind of same info that we had before, so it's kind of masquerading as that cart. So I will disconnect, unplug, take out my cartridge, put this into my Game Boy Color, and turn that on. And look, it's the familiar Tetris. It's playing music too, you just won't hear it. And this is just kind of one of these neat features of the Game Boy Color, is that it remaps the colors that are on a Game Boy game to have a more interesting palette. So we can go ahead and start and so on. So this is straight up a backup now of Tetris, the original Tetris. Irony being that this is a game that you can buy for about $5 or so loose, running on a $20 or $18 flash card. So it doesn't make a lot of economic sense, but it's more useful for cases where you want to test it out on hardware, give it out as a gift, that kind of thing, and not go into mass production on it. Now, one of the interesting things I mentioned before is that there are also these sort of clone games, bootleg reproduction games they're called, that cost very, very little on AliExpress. And this one, you can see it had Perfect Dark flashed onto it at AliExpress seller, but I have plugged it into my little flasher there and put my Game Boy game that I made in Game Boy Studio on there. So I can say play, and probably get a lot closer here. Let's see if we can make it at all legible. Probably not great. Oh, sorta. Let's see if I can tilt it. There we go. So you can see I got Lars into the game now. He says some stuff. He says meow to you. Go into my little other room here, start collecting stuff. So the same stuff that we saw before, just kind of neat seeing it on the color. And that is running on a cartridge that only cost me about $3 plus shipping, and I got a couple of them. So that's an interesting alternative. It may not be guaranteed to work. It may not have real-time clock or battery. Maybe it does, maybe it doesn't. So you're taking a gamble with that stuff, but it is another option. So those are some of the basics there of getting your game onto hardware that you can play and give out. Again, if you're just joining, you're wondering why is he doing all this. There was this Dookie Demastered project from Green Day where they took this album and they put each song onto a different piece of obsolete playback technology, one of them being a Game Boy cartridge, but they only made 25 of them. And so I wanted to make my own, and I wanted to show how you could do it yourself. So I'll be working on the guide, first of all, just some basics of getting started with GB Studio so that you can make a very simple little game, create some music for it, and then how to pick some hardware to put it onto if you want to be able to give out cartridges to people, put your own labels on them. This stuff can get pretty inexpensive, actually. So the gear I'm using for this, inside gadgets, GBX Cart RW. So these cost anywhere from $33 to $37. They are available in a few different countries. There's a US, you can buy it from Australia, which is where this company is, or a few different international shops, Retro Game Repair Shop in the US, Z Labs in the UK. It's actually where I bought it from because they had it in stock, so I had to wait a little and pay a little extra for shipping. I think it cost me $40-something. Retro Modding in Canada and Mod in France, and you may find it elsewhere. This is a really nice one. I think there are clones of it that are on eBay. I haven't tried them, so I can't tell you how well they work or not. I think most of them look like they're based on an older design. This seems to be a very nice, newer design. And there are a few different things that do this sort of stuff, so if you research it a bit, and I'll probably put a couple alternates out there. Also, again, these guys sell a nice cartridge that's very similar to this Ferrante Crafts one. Also, it was out of stock, so I ended up getting the Ferrante Craft one. And let's see, you'll find carts for different types of specific needs. I wanted to get one that could do 512K. So this one here is a 32K, and I think this is the 512K or vice versa. I don't know which one I'm looking at there. So slightly different design from the Ferrante Crafts one. I'm not sure if they've just integrated some of the logic chips into one package there. But these are, these are the ones you can get a custom boot logo on. I think it might be a little cheaper to do one that doesn't have that. Let's see, where'd that one go? I can never find that one, but yeah, there is a 512 for Game Boy. Where'd you go? This one, ROM only, yeah. So this one doesn't have the custom logo on it. So yeah, $11 to $14, so not bad. The 32K one, I don't think you're going to be able to put custom games on it unless you're writing them in assembly, like to keep them really, really small. There's some overhead from having GB Studio create it or other sort of drag and drop tools create it. So you're going to have a slightly bigger cartridge. So yeah, here's the 32. It's just directly mapped pins to pins. So those are dead simple. You could probably make that one on your own. You could probably wire that on a breadboard and an edge connector. but these ones have a little more going on to do the memory mapping of the different blocks. So that is both the writer and some of the carts there. And you can also just get one of these things to read ROMs if you want to grab ROMs off of cartridges that you have and play them legitimately in an emulator or an FPGA. That's another way to do that. Excuse me. Over in the chat, in our YouTube chat, XN says, man, after DEF CON this year, seen lots of people come around to GB Studio and how sick it is. Yeah, it's incredible. I won't show any of it today, but I was showing some of it last week. So if you want to go back and look at that episode, or maybe it was the week before and last week, I poked around a little in there to show you some of the basics of setting up your game. All right, let's... Oh gosh, Squid.jpg says, Nintendo used to cease and desist anyone that had the Nintendo logo on their ROM. Ask me how I know. Okay. I imagine you put something out there with the Nintendo logo on it, huh? Yikes. I don't want to get sued by... I don't want to get letters from lawyers from Nintendo. They're terrifying. All right, good to know. Yeah, I will look and see how I can keep that logo off of my ROM. I haven't dug into how that process works. So thanks for the tip on that. And if you know how to pull that off of there before it goes onto the cart, or update the cart to not have the logo, I guess it lives on there, let me know. I'm interested in that. Okay, let's see. I think that's it. I'm going to put this stuff away. That's it for Game Boy stuff for today. Oh, I will say there's one other cart that I just got, verified that it works. This is from a company called Funny Playing. It was a neat Midnight Trace clear solder mask type of board. It has a clear-ish case, but it's not crystal clear, so you kind of can't see stuff until you take it off. This one has a real-time clock and a battery save and dip switches for setting the memory bank controller type while you're flashing it. Or maybe when you're playing it back, I can't remember which. So a lot more involved, but this one does work, I can confirm. It was hard to find out on the internet if this one would actually work with that flasher. It does, so I'll let some people who are wondering know about that. Interesting thing about these guys, Funny Playing. So this is the board here. You can see a little better there outside of the case. So this is a 4 meg flash, 128K FRAM for game saves. And it has the real-time clock, the batteries for the real-time clock. 8 meg ROM accessible in memory bank controller 5 mode. Coin cell only required to retain real-time clock, not for retaining the saves. So this one, they made it specifically for their own little cool gizmo, the Burnmaster. Burnmaster I'm fascinated by because of the incredibly cool injection molded case they built for the thing. But it's also kind of weird because it doesn't hook up to a computer. It is actually a handheld ROM dumper and flasher that uses an SD card. So no computer involved, it's all right there. So you can plug in a cartridge, save it to the SD card, and then plug in a blank and write to it. It's battery powered, it's portable. So pretty cool. And I may get one just because of the case, or maybe not even get the thing. The cases are pretty cheap, but just get the case because I kind of like this form factor of using proper size Game Boy buttons and D-pad as a sort of universal input. And you can see they're doing the little fingers there that get pressed by the little carbon conductive dot on the bottom of the silicon pad. So pretty cool. And anyway, they made that cart specifically for this thing. They're known to be compatible, but looks like you can also use this without that particular little burner thing, which I probably don't really have a use for, but That's neat. All right. So let's dive into some of this DMX stuff now. I'm gonna switch over here to talk about this. Let me just bring up my. Turn off that fan. I'm going to bring up my chat so that I can see if any audio issues or things like that happen. And yeah, I should probably, let's see. I switch these cameras up. Probably do that. Let's go to the main cam and the bench cam. Sure. And I'll turn on this light here, which I forgot. I'll leave this other spot off. Okay, so let's bring up Discord here on the phone. Step 1. And my broadcast chat. There you are. Seeing behind the curtain, it's true. Okay, so I'll put that right there. DMX, what the heck is all this? What are we talking about here? So you may be familiar in the microcontroller world with our NeoPixels, RGB pixels with a little per pixel microcontroller that allows you to send data about the RGB or RGBW color that you want an individual pixel. In the theater lighting world, in show lighting, in Las Vegas, in clubs, there is an older standard that's been around probably since the mid-'80s, around the time of MIDI, of sending serial data to fixtures that can be lights, often lights, but can also be things like fog machines and motorized things, to tell them what to do. DMX is like digital multiplex or something, I think is what it stands for, often called DMX512 because there are 512 channels that can be sent on a single universe, which is sort of one instance of DMX, and you can get more sophisticated and have multiple universes if you have a lot of gear to deal with. So the interesting thing is that 512 bytes are always sent, and they're sent kind of on the regular to all devices, and they are passed along down a chain. So I've got two light fixtures here that are, in fact, let me turn this light on for a second so you can see the gizmos a little better. So you've got data coming into and then flowing through to the next one, to the next one, to the next one, to the next one. They all have their own separate power supply, so this is just data over this XLR cable here. The spec says it should be a 5-pin differential pair cable. In reality, a lot of people use 3-pin XLR, which is what microphones use and other audio gear. They're not technically correct, so in critical situations you wouldn't use them, but a lot of places people save money by using the cheaper 3-pin XLR cables. If you look at that right there in the little down shooter, let me see, can I switch views there? There you can see that's a 3-pin XLR cable. These are gendered, so you will have a output with a female connector and a male end cable, and then it is the opposite on the other side. And so every cable is always going to be gendered like that. I'll switch this view again here. So the kind of nice thing about the way DMX is configured is that your fixtures don't have a fixed address until you give them one. So both of these lights could show up as channel 1 for brightness, channel 2 for red, channel 3 for green, channel 4 for blue. Or we can tell the light, and they'll usually, you see blinking here, they'll usually have a little panel or dip switches. This one has a little visible interface and some buttons to say what its first channel is. So I've told this one to be channel 1 as its first channel. And then however many functions this light has, it will use that many subsequent channels. So in RGB mode, this has 4 channels. It has a brightness overall channel, and then it has a red, a green, and a blue that it can use. And it doesn't need to worry about anything else. So technically speaking, I could set this next light up as channel 5, 6, 7, 8. 5, 6, 7, 8, 9. No, 5, 6, 7, 8. But it's also fine to spread them out any way you want. I happen to have set these up as if they were each 16 channels, just so there's some breathing room there. I think this one can be in a 7-channel mode because there are messages that it can receive to do features that were just kind of programmed into the light. So this one can go into like a blinking mode and a color cycle mode. So all of those kind of fancy modes that you'll often see on a little cheapy IR remote are in these cheap. These are like $30 for 2 of them kind of lights. So real inexpensive lights. But there are things like filters that are motorized to move in place, or gobos, which cast shadows that can move into place, spinning elements, pan tilt, changing the focal length of a lens to adjust a spot. All those kinds of things will each be their own individual DMX channel. So enough talk, let me show it in action. This is, what you see here is a little inexpensive, like $45, $40 DMX controller. This is on the compact side. Typically you'll get ones that are about this big and just give you more space, but basically the same functions, and are rack mountable, so they'll be 19 inches wide. And these, I don't know why they do this, but they cut costs, and they actually only support 192 channels, which is probably just an arbitrary, I don't even know if they're saving any money on that. It's maybe you need one more UI button to flip over into the others. I can't begin to guess why they limit it to that, but we'll still call it DMX512, even though this one only does 192 channels for whatever reason. And if anyone knows about that, please let me know. I'm curious what the thinking is of limiting that. So on this controller, I've got 16 different fixtures or sets of channels that I can call up quickly. Again, it's just a UI choice. The protocol doesn't care. You could have 512 buttons to pick from in one slider. This one has 8 sliders and 12 of these buttons. If I go to the first one, this actually covers, actually that's why I set the lights the way I did. This one covers channels 1 through 16. So it covers 1 through 8 with these sliders, and then I think you hit page select, and then you go 9 through 16. If I hit this second sort of set of channels, that's going to start at 16, and so on. So if I enable the first channel, this one here is set to be channel 1, and 1 through 16 technically. If I then go and give it some brightness and at least one of the color channels, you'll see that lighting up. It should be making me light up red, and you can see the lights in the overhead view there on the camera. So you can probably guess the way they do this is they put individual LEDs that are red and then a set of individual LEDs that are green, which is looking a little bluish on my camera, sorry. Excuse me, and then a separate set that are green. And these, to look at them, you're like, well, that looks like a mess, but if you actually light up my hand, it's pretty white. This isn't a great white, but it's pretty white. If we want to go like yellow, we can do red and green. You can see really clearly these are just red and just green, but at any distance, let me back off the brightness there, it'll look like a mixed color. Same if I point this down at, I can point it at the camera. If I point this down at my workbench, particularly in the bigger camera view there, you can see, you can mix that to just be a red. Let me bring up the brightness. Mix that up to a yellow, make it kind of purple by bringing in blue. Sort of aqua, just green, just blue, all colors, right? So brightness control, you may be thinking, hey, that's pretty similar to NeoPixels, and it is. So you've usually got a brightness overall, which can be achieved different ways on the device. So, you know, a higher quality light is probably a constant current type of thing. For the brightness, and then red, green, and blue would usually be a PWM, but maybe a constant current of those individual pixels or LEDs. So let me flip that back around so you can kind of see the light itself. And now if let's just make this one red for now. If I punch over to my second set of channels right here, so I've gone and said, let me switch these around. There we go. So that's banks 1 through 16. This will be 17 through whatever that is, 25 or something. Now if I touch these faders, I'm going to be messing with this other fixture. So this one is channels starting on 1. This is channels starting on 16. So I can make, let's say, this one blue over here, this one red. I'm using the same faders, but I'm picking which fixture I'm dealing with, which set of DMX channels I'm dealing with. If I want, I can go to both of these and just deal with their brightness. And if I touch any of the colors, then I'll be sending those colors to them both. So if I, let's say, just crank up green, now they're both green, and I can control them at the same time because I'm sending to those banks, which is nice. It works out the offset. Can keep them independent, like that. And then depending on the controller you have or software, because typically in a more sophisticated setup, instead of relying on a little hardware device like this, you will use an interface control surface along with software to create more sophisticated lighting scenarios. So what I mean by that is you can dial in, let's say you have 3-act play and you want to have a number of scenes in Act 1 that go from morning to evening to blackout, and you want those 3 setups with however many lights you've carefully sculpted in there. You can save that, all of those fixtures, so all of those 512 DMX messages as a preset, and then fade in that preset or just jump to that preset, and then decide when a cue gets called to move to the next one, move to the next one. You can also do things like have it run through a set of scenes for you automatically. You can have scenes changed based on other inputs. So on these DJ dance floor kind of controllers, often there's just a microphone input. This one I think has a microphone input built in. Others will have an audio input to the device. So you can sync, you know, a couple scenes to rotate back and forth with that. So I've messed with this little controller just enough to be able to punch between a few scenes. And so if I just hit scene 1, you see it doesn't matter what any of these other sort of faders and channel choices are set to right now. I've got those off, but I can go to pre-programmed setups. So my first scene is just one light, red. Second scene is the other light, red. Third scene, green, green, blue, blue, and then nothing on. I didn't put any on 7 and 8. So those don't have to be just exclusive like that. Of course, it could be they're both red. One's red and green. Then the next scene, one is dimmer but the same color. Any mixing you want, and these can all be fully mixed colors. They don't have to just be the individual red, green, and blue, if that makes sense. So let's see. that's the basics of our DMX. And then where I think it gets kind of interesting is this notion of being able to send out these messages not from a little canned controller like this, but from a microcontroller that we can program. Or send stuff from this to a microcontroller, which can then filter and massage and do other things with that data before sending it off to the fixtures. So what I want to do is I'm going to see if we can flip these lights around so we can still see them, and then I'm going to go over to the computer and control, not from this is unplugged, but from a microcontroller. So there's my DMX cable that's running into the first fixture, which then has a second one to chain it to the second. So I'm going to go grab that and plug that into a little DMX shield for Arduino. So let's go to this view of the world, and let's bring up Arduino on here. I'll put this right here, and I'll get that into focus in a second. Let me hide that, show that, and link that to an Arduino window. Serial, sure, this is a good one. Okay. Let me actually find that window. DMX, simple, serial to DMX. Okay. So here's the setup here. Let me fix this focus here. So what I have is, I'll go ahead and unplug this. I have a Arduino Uno here, old school Arduino Uno, and on it is a like $15, if I remember correctly, shield that has a couple of our DMX connectors there. These 3-pin, you might think of them as XLR, not DMX, but we're using them for DMX. These little XLR connectors here, nice Neutrik ones, and a RS, what is it, RS485? Is that the protocol? I can't remember, I'll have to look that up. But there's a serial data UART protocol that's used for all this. And this one, if we take that cable there and plug it to our output, is now going to be able to send the same kind of DMX messages over to those lights there, which I think you can see. I'm going to turn off this, or just point this spot elsewhere. So if you take a look at my Arduino window here, what I'm going to do is actually send it a direct message from serial. So there are, I'll show you some links to these, and I'll put together a guide on some of these basics. There are a couple of popular shields for this kind of stuff. They're all kind of doing the same thing. This one is from Conceptnetics, I think that's the name of it, Conceptnetics. And it can use a number of different libraries that are out there on Arduino. You could probably cook this up for CircuitPython too, and we may take a look at doing that ourselves. And one I'm using here is actually called DMX Simple. If you're in Arduino and you just simply go to the library manager, a bunch of these are in the library if you just search for DMX. So I'll go right here to library manager, filter for DMX. You'll see there's an Arduino DMX library by Arduino that's bare bones. It'll just send, I don't think it'll receive, using an RS485 shield. Yeah, that's the name of the protocol and the chip you'll use. The DMX Simple right here by Peter Knight and Tinker It. I like that one. And I think I installed separately, there's one from SparkFun that's for their ESP32 Thing Plus that looks kind of neat. And on this one I don't have it installed. There's another one, the library from conceptonetics or conceptnetics themselves, which also works well. But with this DMX simple library, there's a couple of examples. Let me close this back down here. And I'll take you through a little bit of what's going on here, but let me first demo. If I tell it a channel, so you probably can't see this too well, but right down here I'm going to type 1C, so channel 1, and then a value. I'm just going to set that brightness value up to 200 and a W. And then I'm going to say on channel 2, so 2C, let's go to full red, 255W. Hit enter. So you see this light right here just lit up. Should be able to see that in the background, so keep an eye over here. So this is the light on channel 1. And then I can say, let's do the same thing, but on channel 16. And I'll make that one green. So I'll say channel 16 is the brightness, and channel 18 is green. And I'll actually hit enter. I think I screwed that up. Let's see. 16C, 200W, 18C, 255W. Oh, that's not what I expected. What did I do wrong? Did I mean 19? Let's see. Oh, yeah, 19. Okay, so let's do... Oh, that's funny. No, it should be 17, not 16. Okay, 17. And then 19 was green. I'm going to turn 18, which is red, down to 0. Boop, a little better, and that's very bright, so I'll actually lower that one. I've noticed on these lights, red is a lot dimmer than green and blue. So let's set this down to, how about 100 brightness? Drops that quite a bit. Let's go even lower. 60. All right, that's a little better. So this is kind of cool because now we have just the syntax for how to send these messages. Way this works, we have a pin that we're transmitting on. In this case, I'm picking pin 4, and that's just what this shield wants. If you're not using the TX, it has a little jumper to say, okay, we'll transmit on pin 4 and we'll receive on pin 3. And this, by the way, this other port on here, this is the receive port, so that means that we can plug something like that controller or your computer in and receive the messages over that, that XLR port there. But in this example, I'm just sending. There's a mode select, which puts this into sender mode instead of receiver mode, and I believe you can toggle that as you go to get messages and send messages, but I haven't played with that. And then in our setup, I'm setting the mode select pin output high, so that tells it, okay, we're a sender, not a receiver. I'm picking my transmit pin. I'm picking essentially the size of the message, the maximum number of channels, 512. One interesting thing I've seen is some of these libraries will say, oh, you can pick a different maximum number to send a shorter message, but a lot of fixtures don't like that. So if you get weird behavior because you're like, oh, I've only got 4 channels, I'll just tell it maximum number of channels is 4. The message, I don't know, doesn't make some fixtures happy that I think aren't just looking for like a stop bit on it, but they're looking for the full complete 512 byte message to come through. And then this one has a little serial setup so that we can just type in the serial monitor input here. You can set, in this case, I was just making my life easy by setting the faders up to full brightness at the beginning, so I don't necessarily have to adjust those, but that's just a convenience. And then the main loop here is a bunch of code to see what you've typed in. So all this is the serial code, reformat that, and then send this message. This is the only message that matters. DMX simple.write, the channel number, and the value. So values in DMX are 0 to 255, and then the channels will be 1 to 512, whichever fixture you have. A different example I'll show. I'm going to reload this right here. Is that one? Did that update? Did it? Didn't look like it did. Hold on one second. There we go. This a little bigger. Fill that space up. So this is an example that we'll just do some fading. So here again, I've got my transmit pin, my mode select, and then I'm just doing some initial settings that will set channel 1 to half brightness and channel 17 to half brightness. And then the red, green, and blue channels on fixture 1 are at 0, and the red, green, and blue channels on fixture 2 are 0. And then my loop is just going to run through some color patterns. So let's see if I can convince this board that I mean business, and I'll re-flash the Uno that's plugged in under there. And there you can see I've just got this little hold a second and a half on a color, blank them for half a second, go to the next set of colors. These should be happening instantaneously. I will say sometimes due to the cheap construction of this and the red channel being way dimmer than the other two, it looks like red, that whatever fixture is doing red is coming on like a moment later, but that's not DMX's problem. It's just the cheap fixtures that I'm using, so I would probably have to essentially gamma correct these, compensate for what brightness level red should be at to be equivalent perception to the green and the blue channels there. But this is just some simple code here that is blinking them on and off. I think the example started out as a fade loop. Let's try that. I can't remember what that looks like. I haven't looked at that one. So it's going to create a integer variable called brightness, and then from 0 to 255 it'll write the fade up pretty quickly, 0.10 or a 10 millisecond delay, and then it'll blank them again and hold for a second. I think I need to actually set, I'm going to give these a color to begin with, so let's do a blue one and a green one. So I'll do 200, 200. Okay, so fade up, blank, fade up, blank, fade up, hold, blank. And that's very straightforward, simple little loop there, but you can imagine we can maybe extend this out. Let's make it a little slower, get a nicer fade on there. Tyeth asks, does DMX have any commands, or is it all driven by the host setting brightness per channel? My understanding, it is all set by the host setting brightness per channel, yeah. Some of the, I think maybe this library has a command that makes it easier to set like a range. You don't have to write it yourself. I think you can do like a range of channels all set to the same value if you just need to like suddenly blank things or whatever. Abatus says, if you put the red and blue in your car, you can get through traffic faster. Yeah, yeah. So I think I'm gonna, after we're done here, I'm gonna set these up outside to do some Halloween lights there. And of course, I'll stop this thing now. So let me just disable this shield. Has a nice little disable, enable pin. I think what makes this interesting is you can now add to your microcontroller whatever the heck you want, right? You could do wireless stuff with it. You could use sensors, distance sensors, that kind of stuff. I had a pan tilt wash servo that had lenses and gobos and stuff kind of all built into it that I had just found a few of them on the side of in an alleyway one time actually. They were enormous and taking up space. I showed it on this show 4 or 5 years ago, I think. I got rid of them, but I think a very good friend of mine and a friend of the show, Todd Kurt, still has one that I gave him, and I may be borrowing that from him if he'll let me, and show it off here as I develop some of this stuff. But yeah, you can imagine with a microcontroller involved, you can do anything. One of the hopes here is convincing Limor that maybe we should do our own take on a featherwing for DMX or a shield for DMX, and get some nice CircuitPython if it can handle the timings of writing out the data with the proper clock on this this little RS-485 chip. Then maybe we can do a cool little gizmo. Mark Z in the chat writes, let's see, RDM, or remote device management, works by sending pulses of data down the DMX line in between the normal DMX commands, while the DMX protocol originally left pins in 4 or 5 the XLR connector open for future use. RDM doesn't use them either. Oh, that's funny. One of the most common misconceptions of RDM. Thank you for that info. Yeah, I'll have to learn more about the remote device management side of things, because I've run across that. I think this shield does do the RDM stuff, but I'm not sure. I'm unclear. Yeah, I'm pretty new to DMX. I've kind of used it in a really controlled settings in theater a long time ago, and haven't touched it in forever. So I'm not a DMX expert, but hopefully you'll enjoy the journey of me at least getting some of the fun basics going, so that you can take advantage of this. And like I said, that you can get $30 for 2 lights kind of stuff on Amazon or wherever, up through to really high quality gear. Someone asked, I do not have experience using this for architectural lighting, but I know that it is used for fancy indoor, not just residential, but museums and things where there's a protocol sitting there waiting to be used to do things like very specific preset saved patterns of light brightness or color, and so on. There's nothing to stop you from using this with something like a particular warm to cool color temperature light that sometimes is made from multiple LED diodes in different color temperatures. Landscape architecture could be another as well. And then, like I mentioned earlier, one of the interesting sort of flip it on its head uses for this is to say, okay, if we don't send at all, but simply receive, so we plug in something like that controller, you can write code to kind of do anything with that. So I'll do an example with NeoPixels. If we just have a NeoPixel strip and we want to control it from that kind of controller, well, DMX to your microcontroller, and then NeoPixel color code out the other side. And it doesn't just have to be simple like fading in and out, but it can be the percentage of a animation speed. We could slow it down or speed it up. We could flip between patterns. We can drive motors with it. You can kind of do anything once you get it into microcontroller land for props and effects and animatronics and things like that. So that's where that's going. So let me turn, it's getting hot in here. I'm going to turn this back on. Cool things off a bit. And then the last thing I'll do is I'm going to do a little bit on the continuing journey with our 3D modeling and CAD intro here. So I'll mention this again. I am doing some basics of parametric modeling and CAD, which apply to most modern 3D modeling and CAD packages. I'm using Rhino. This is not me saying you should go and drop everything and get Rhino. It's just a nice one that I've used for a long time, so that's what I'll show it in. But most of the principles here will apply in anything from Blender to OpenSCAD to Fusion 360 to you name it, for both modeling with solids, modeling with NURBS, modeling with sub-Ds, modeling with polygons, and then parametric modeling, so creating a data flow that can create your end result with not just one baked in user session, but instead numbers and massaging of data to output the thing you want in the end. So last week I started talking about parametric modeling, taking little parameters, little nodes, and putting info into them and then getting a result out of them and being able to go back to the beginning of that and change things. So I wanted to show a little more concrete example of that. So here we can see I'm going to build something like a 3D printable base for a breakout board, that sort of thing. And maybe I'll get more specific with like a particular board or a feather or something in the future. But this is just generalized I want to build a rectangular thing and I want to put some holes in it in a particular place, and I want to make everything have particular dimensions, and I want to be able to adjust that to maybe deal with different scenarios. So the example that I have here, I'm starting off with a node that is for creating a rectangle. I've actually got two of them, and we'll talk about why. So there you can see I'm making a rectangle, and that is a node that just does that. We showed last week how to do this a little more elementally by creating points and creating lines between the points and joining them, but this is a convenience node that says, okay, so I hear you want to make a rectangle. Pick a plane, and this one by default picks the XYZ plane of the world at the origin. That's what this little grid at the bottom left corner is. And feed into it a size in the world units that you're using. I'm using millimeters. And we can also feed into it a radius if we want to fill it get those nice rounded corners. So you can see here I'm just keeping this one on the grid. So I've got a little slider that is integer slider, so I can't go parts of millimeters, just to keep things clean and simple. But here is a rectangle that I'm parametrically controlling. If we look at the neighbor, and I'll show you why there's a neighbor in a moment, I've also got a little control there that I gave myself for being able to adjust that radius of the corner fillet. I also put in a little logic for moving the thing around. So if we look at this one here, I can slide that around in space. I'm just moving it a unit away from the origin. I'll just leave it there. And that is kind of collected in this little group here. So for myself, I've just taken those nodes, put them into a little group, and I've named it Create Rectangles. Then I'm also taking that initial curve and offsetting it. Let me pick this one and this one. So I have a offset of the curve, so I can just dial in the dimensions and then say, how far in do I want the holes that are going to be in the corners? So I do that by taking the exact same initial rectangle and then deriving an offset, a proper offset, any distance I dial in. So as I bring this in, it's getting from 1 millimeter, I made that my minimum, to 20 as my maximum here. So we'll just eyeball that somewhere. Let's say I like it there. The plane, or rather the rectangle that's created by that offset, I'm then saying, you know what, I want to find out where its corners are. That's actually why I made this. I don't really need that rectangle. What I need is 4 points that are offset the right amount from the overall board's corners. So I'm using this deconstruct the binary representation, deconstruct rep, of that rectangle, and then I can take that and make all of my little circles from it. So if I look at these nodes here, these are all starting from me finding out where the vertices are, And then that generates this little list. I'm just displaying them here to see where they are, but those are the coordinates of 4 points, 4 vertices, 4 corners. I can then just break out each of those 4. So here's one, here's one, here's one, here's one, and tell it to put something there. So I'm using these little create circle nodes and putting those at those 4 corners. So if I look at those and the initial deconstruct rep, that's how I'm getting circles at those corners. If I also select my initial board there, you can see that's where those circles are going to be. And I'm using a mode here where nothing shows up until I pick something. That just helps me, like, as I touch a thing, I can see without having to hide stuff or move things, how everything's made. So if we go back to the initial rectangle, now I can go and tell it, okay, let's make an actual surface from this 2D rectangle. Let's take this thing, let's put some skin on it, and then let's extrude that up some amount. So again, I've got it with a little slider here. I can make that a little thicker, let's say. And that takes care of the board. So now I need to take these circles that I made, and if we look at these 4 circles there, I can do also the same sort of thing, an extrusion on those to make these kind of little pegs. And I'm going to use those to cut out holes. So by taking the output of extruding that rectangle up as a solid board and those 4 little pegs that got capped, I can then drive those into this thing called a solid difference. It's a Boolean. It's saying we'll cut out things. And then the last thing I'm doing here is just putting it into a nice, let me hide this mode for a second, into a nice preview. Oh, you know what? Let me do one thing first. One added benefit of this is that I can do things like connect dimensioning feedback. So if we want to see as we're building it the size of it, now I know, okay, this is 64 millimeters on a side by 47 on a side, and the distance between the centers of those holes is 36.5 here and 53.5 here. So if I go back and start adjusting, let's say, the width of the thing, that's that same number, right? 51 millimeters wide now and 36 high. If I adjust the offset distance for those holes, I can bring them in closer, and you can see their number is shrinking. So now it's just 10 millimeters away. I can also do a slider for the radius of those holes. So if I want to use, let's say, 3 M3 screws, I will make that like 3.15, 3.2 diameter. So here you can see as I increase this, I'll just get bigger size holes. And we could add that too. I could add a little on-screen dimension that tells me what size holes am I using, just to remind myself when I'm looking at this and creating it. So that is a more practical use of this type of parametric modeling. And you can see, okay, that's a lot of steps. You know, it's the logic of and the interface of what I've done. But some of these are really reusable too. So we could do things like make some of this complexity hide. If I take this little group of nodes here, for example, and cluster those up, now it's a much simpler. I don't really need to dig around in there. Really, I just want to mess around with this diameter of the holes here. And we can do that throughout. So we can make these into a little more easily digested pieces. We can undo that or uncluster that to bring that back. So it didn't go anywhere, but it just kind of hid some of the complexity. And you can even do things like, say, I just want to make one node, and all it has is inputs for those sliders and an output. So we could condense this all into a single thing, which makes this scene easier, but that can also be exported as its own little reusable cluster that we can bring in to other scenes. So you can make a building block of, okay, I do a lot of mounting PCBs to things, I just want to bring that in, start from that, and then we can build the rest around it if we wanted to say, okay, I need to offset it again and build some walls and build a lid and put some mounting brackets. All of those could be little parametric bits of data that give us our end result. And that end result is going to just be this model. So if we look at the very end of the chain here and take that PCB, I'm just going to bake this. So this is turning it into real geometry. I can now go over, let me turn this mode back to hide all that stuff. I can now turn this into an actual piece of stuff that I can pick up in my 3D view here, do other things to it if I don't need to be parametric anymore, export it and go 3D print it, export just the lines and use it for a tool path for a CNC mill or a laser cutter. The fact that we have this precise, reproducible, easily adjusted thing that uses real-world units gives us a lot of freedom to build the stuff that we want to use in our projects. So I'll end that there, but that's the sort of basics of a practical example of putting together a real-world object that we can adjust with sensible parameters for what we're trying to do. All right, I will close that out of there, come back here, and remind you once again, oh, those spotlights look kind of like a face now. I like that. It is Halloween today. Thank you for stopping by on Halloween. And this is the coupon code for you if you want to go buy some stuff before you go out trick-or-treating or giving out some candy. I'm going to go hork down some candy corn. All Hallows Eve is your coupon code, all-hallows-eve. Go to adafruit.com, type that in on the way out, and you'll get 10% off on your stuff, physical things that you order today. That expires midnight tonight, East Coast time. All right, that's it from me and Lars over here, who's also in disguise. Thanks so much. This has been John Park's Workshop, and I will see you next time. Thanks, everyone. Bye-bye.